Welcome to the Copperfield Electric Podcast.
Thanks for having me. I'm really excited to get into this one.
So imagine treating a $60,000 piece of advanced engineering like a cheap disposable smartphone.
Right, which is exactly what so many people are doing right now.
They really are. I
Yeah.
mean, you pull into your garage at the end of the day, you plug the car into the wall, and you just force that battery to absolute maximum capacity.
Yeah, and then you just leave it sitting there, slowly cooking the internal chemistry under immense voltage pressure.
Exactly. And it's happening because a massive percentage of new EV owners are just carrying over these outdated habits from the era of gas stations. We're so used to just filling the tank.
Right, you just fill it up and forget about it, but that doesn't work here.
It really doesn't. So today we are pulling directly from the expertise and technical sources over at Copperfield Electric to uncover the actual mechanisms behind smart EV charging.
Which is a complete game changer if you actually use it right.
Totally. The mission for this deep dive is to show you how optimizing your charging strategy doesn't just save you a massive amount of money, but actively extends your vehicle's battery life.
And protects your home's electrical panel from critical overloads, which is a huge deal.
Oh, massive deal. Okay, let's unpack this. Because when you look at the raw data and the physical science of what happens during a charge cycle, the specific numbers are honestly surprising.
They really are. I mean, taking control of that charge cycle is the fundamental difference between just being a passive consumer of electricity and acting as an active manager of, like, a miniature power plant in your garage.
Yeah, people think the car is doing all the work.
Exactly. A lot of drivers assume the vehicle itself is doing all the heavy lifting regarding power management. But the reality is, true optimization requires taking granular control over the timing, the speed, and the dynamic cost of the power.
You have to tell it what to do.
Right. It transforms the entire ownership experience from guesswork into a highly efficient, automated system.
So to get to that level of automation, we really need to talk about the hardware versus the software.
Yeah, specifically looking at the delta between a standard level 2 charger and a smart level 2 setup.
Right, because I think you guys, our listeners, already know that the level 1 plug that comes with the car is, well, it's practically useless for a daily commute.
Yeah, it's just trickling out a tiny bit of range, maybe 3 to 5 miles an hour.
Exactly. And they know upgrading to a 240-volt level 2 circuit is pretty much the standard baseline now.
It is, yeah.
But the sources highlight something really interesting here. The physical hardware for a basic, dumb level 2 charger and a high-end smart level 2 charger is practically identical.
Yes, this is what trips people up.
Mhm.
We are talking about the same 240-volt circuit, the same wall-mounted enclosure, the same heavy-duty copper wiring.
And the exact same standard J1772 or Tesla connector, right?
Right, exactly. The electricity flowing through the cable is identical. What's fascinating here is that the transformative element, the piece that changes this from a simple extension cord into an energy management tool, is the software layer sitting on top of that hardware.
Okay, so it's all in the brain of the unit.
Right. A smart charger incorporates a built-in computer, usually connected via your home Wi-Fi, and is running complex protocols.
Like the OCPP thing mentioned in the sources?
Yeah, exactly. The Open Charge Point Protocol. Think of OCPP as a universal language. It allows the software inside your charger to communicate seamlessly with third-party networks, your utility company servers, and your smartphone app.
So it's not just a one-way street pushing power.
No, it is a two-way data stream. A basic charger only pushes power. A smart charger pushes power while simultaneously exchanging thousands of data points about grid load, battery state, and real-time electricity pricing.
I look at it a bit like a household plumbing system. A basic level 2 charger is essentially like a heavy-duty garden hose. You turn the spigot, and it just blasts water at maximum pressure until the pool overflows.
Or until you manually walk out there and shut
Yeah.
it off yourself, yeah.
Right. But the smart charger, running on that OCPP software layer, is like a high-tech algorithmic irrigation system.
I like that analogy.
Thanks. Yeah, it's like you program the exact saturation levels you want. The system checks the local weather forecast to see if it's going to rain, checks the evaporation rates, and then precisely dispenses the exact number of gallons needed at like 3 in the morning.
Yeah, you are managing the flow based on external environmental data rather than just leaving the tap open.
Exactly.
That is a highly accurate way to visualize the mechanism at play. Because you aren't just dealing with a dumb pipe pushing electrons, you are operating a sophisticated node on the electrical grid.
Wow, a node on the grid. That sounds intense.
Well, it is. The software knows the specific limitations of your car's onboard inverter. It knows the historical pricing data from your utility, and it coordinates all those variables automatically.
Okay, so that level of granular control brings us directly to how we manage the physical battery itself. The sources heavily emphasize this 80/20 rule.
Yes, the golden rule of EV ownership,
Right. The baseline advice is to use the app to limit daily charging to exactly 80% and to try to plug in before the battery drops below 20%.
which is absolutely crucial for battery health.
But wait, so I shouldn't fill the tank every night like I always did with my gas car. I want to push back on this a bit.
I hear that a lot, but no, you definitely shouldn't.
It just feels so counterintuitive, Like I want a full tank when I wake up.
I get that, but you have to look at the chemistry. Staying in that middle 20 to 80% zone drastically reduces cell stress. We are talking about extending the life of a battery that costs thousands and thousands of dollars to replace.
Just by not charging it to 100%.
Yeah, for the vast majority of EVs on the road today, using standard NMC nickel manganese cobalt lithium ion packs, the 80/20 rule is absolute gospel. Pushing those specific cells to the extreme, top or bottom, creates immense physical stress.
Okay, so what actually happens inside the battery when you do that?
Well, when you forced electrons into a cell that is already 90% full, you are fighting intense internal resistance. That resistance generates heat, and heat physically degrades the internal structures of the battery over time.
Okay, that makes sense when you think about the physics of it. It's kind of like packing for a long vacation.
Of the suitcase analogy, yeah.
Yeah, like throwing the first 80% of your clothes into a suitcase is effortless. You just toss them in. But getting that last 20% in requires you to literally sit on the suitcase, carefully shoving socks into the corners, straining the zippers.
That is exactly what the battery is doing, which is why charging from 10% to 80% happens incredibly fast, but that last 20% takes a painfully long time.
Because the car is throttling it.
Right. The vehicle's onboard computer actually throttles the charge curve down to a trickle to prevent the battery from overheating while it stuffs those last few electrons in.
Wow.
Which is exactly why sticking to the 80% limit for daily driving doesn't just protect the battery, it radically speeds up your daily charging sessions. By stopping at 80, you are exclusively operating within the fastest, most efficient portion of the battery's charge curve.
So you basically reserve that grueling, high-resistance, 100% charge strictly for, like, long road trips where you actually need every drop of rain.
Exactly. Only when you absolutely need it.
Okay, so since we are operating in that highly efficient fast-charging window, it opens up a ton of flexibility for when we pull that power. The timing is where the financial aspect of smart charging gets really interesting.
Oh, the financial side is huge, especially when you look at time of use or TOU rate plans.
Right. The data from Copperfield Electric points out that in California, you are dealing with plans like Southern California Edison's 2UD Prime.
Yes. The Prime plan is explicitly designed to incentivize EV owners to stay off the grid during peak hours.
And the pricing disparity on these TOU plans is just staggering.
It's massive. During peak late afternoon hours, you are paying an absolute premium for electricity. But during the off-peak windows, which typically run overnight from 9 p.m. to 9 a.m., the cost per kilowatt hour drops significantly.
Like, how much are we talking?
We are talking about rates that are roughly 3 to 4 times cheaper.
3 to 4 times? That's crazy.
Yeah. If you consistently shift your charging to those overnight hours, you are effortlessly cutting the operational cost of your vehicle by 30% or more. Over the lifespan of the car, that equates to thousands of dollars kept in your pocket.
And the beauty of the Smart Charger's software layer is that you don't have to, stay awake until 9 p.m. to physically plug the cable into the car.
No, not at all. The software handles it.
Which I love. The sources detail a feature usually called departure time, which I think is just brilliant because it just works. You plug the car in at 5 p.m. when you get home, but the app intercepts the session.
Right. It doesn't start charging right away.
Exactly. You tell the app, hey, I'm leaving for the office at 7 a.m. The charger communicates with the car, determines the current battery level, and calculates that it will take exactly 3 hours to hit your 80% limit.
And then it just does the math.
Right. It mathematically works backward from your 7 a.m. departure, holds off on drawing any power all evening, and finally activates the circuit at precisely 4 a.m.
It perfectly isolates your power draw to the cheapest possible moment in the middle of the night.
It's so cool.
It is. And if we connect this to the bigger picture, this automated scheduling is a vital mechanism for the stability of the entire electrical grid.
Oh, right, because of grid strain.
Exactly. In places like California, the grid is under maximum strain during the late afternoon and early evening, roughly 4 p.m. to 9 p.m. on hot summer days. That is when solar production drops off. But everyone's air conditioning is still running at full capacity.
So that's when you see those flex alerts popping up.
Right? Utilities issue flex alerts to prevent rolling blackouts. And this is where that two-way OCPP communication we talked about earlier becomes incredibly valuable.
Because the utility can actually talk to your charger.
Yes, they actively run demand response programs. They will literally pay you offering $50 to $100 a year in automatic bill credits just for granting your smart charger permission to communicate with their servers.
That's wild. So if a flex alert hits at 6 p.m., the utility sends an API signal over the internet to your Wi-Fi connected charger, and it temporarily pauses the session to relieve pressure on the grid.
Yep, it requires zero effort on the part of the driver, takes just minutes to opt into via the companion app, and it actively stabilizes local infrastructure.
That is just brilliant.
And we can take that optimization one step further by pairing a smart TOU scheduling system with a home solar array.
Oh, the ultimate hack.
It really is. During the peak heat of the day, your solar panels are generating excess power, which is fed back into the grid, often earning you credits. Then, deep in the night, your smart charger pulls ultra-cheap, off-peak grid power to fill the EV.
So you're basically selling high and buying low automatically.
Exactly. The smart software constantly balances this equation, allowing you to effectively drive on sunshine while minimizing your out-of-pocket cost per mile to pennies.
Okay, let's unpack this for a second, because pulling all this cheap, fast power at 4 a.m. sounds fantastic, but what happens to the house?
What do you mean?
Well, pulling an immense amount of power or managing a massive solar offset demands an incredible amount of capacity from the physical wiring of your house. What happens if your home's electrical panel simply cannot handle the sudden rush of electricity?
Yeah, that is a huge concern.
Especially if, the air conditioner or the electric dryer happens to kick on at the exact same time the car starts pulling 48 amps.
This represents one of the most critical safety features of a modern smart setup, which is dynamic load management.
Because not every house is built for this.
Not at all. Many homes, particularly older builds in regions like Orange County, were never designed to handle the continuous electrical load of a modern EV. They might only be equipped with a 100-amp main electrical panel.
And a 100-amp panel is not a lot of headroom.
No, it's not.
Yeah.
If you drop a 48-amp EV charger onto a 100-amp panel and then someone turns on your electric oven, you are instantly going to exceed the physical capacity of the main breaker, causing a complete blackout of the house.
Which is obviously not ideal at 4 a.m. Okay, let's unpack this. I've always thought of load management kind of like a hyper-efficient traffic cop living inside your home's electrical panel.
I like that, a traffic cop.
Yeah, dynamically directing power so everyone gets a turn without causing a massive pileup. But how does it actually monitor the rest of the house in real time to prevent the breaker from tripping?
The mechanism relies on hardware called current transformers, or CT clamps. These are small sensors physically clamped around the main power lines coming into your home's electrical panel.
So they'd just sit there reading the current.
Right, they continuously measure the total amperage your entire house is actively drawing, millisecond by millisecond, and they feed that data directly into the smart charger's microprocessor.
Wow.
So if the charger is pushing 40 amps into your car, and it suddenly detects that your HVAC system just kicked on, demanding 30 amps for the house, the smart charger instantly recalculates.
It realizes the total load is approaching the safety limit of the main breaker.
Precisely. It instantly communicates with the vehicle's onboard inverter and seamlessly throttles the charging speed down to, say, 16 amps.
So the car just accepts less power for a minute.
Yeah, it maintains a safe equilibrium for the entire house. Once the air conditioning cycles off, the CT clamps detect the drop in household demand, and the smart charger automatically ramps the vehicle's charging speed back up to maximum capacity.
Preventing nuisance tripping.
Exactly. Prevents tripping and protects the physical integrity of your home's wiring. This is where data truly becomes actionable.
It really is. And that real-time data flow is also what helps demystify the different tiers of charging speeds, right? The sources provide a really helpful breakdown of circuit amperage here.
Yeah, because level 2 is a pretty broad category.
Right. A robust 48-amp circuit is going to deliver roughly 44 miles of range per hour. But if your load management system or your panel's physical limitations restrict you to a 32-amp circuit, you are looking at about 25 miles of range per hour.
Which is still great, but it's a big difference.
Both are vastly superior to a standard wall plug, but checking that real-time app monitoring allows you to see the actual math happening. If you expect to be charging at 44 miles per hour, but the app shows you're only pulling 15, you instantly know something is bottlenecking the system.
And that data shifts you from just guessing about rate data to actually making informed decisions.
Yeah.
You can quickly determine if the slowdown is a grid issue, a bad cable, or if the car is limiting intake.
Which perfectly transitions us to the foundational premise of everything we've discussed today. All of these brilliant software features, the OCPP compatibility, TOU scheduling, load management, they are completely useless if the physical wiring behind the wall is compromised.
Absolutely useless and honestly dangerous. The
Yeah.
software relies completely on the integrity of the hardware.
Right.
If an installation utilizes undersized wire gauges, has a loose neutral connection, or employs the wrong size breaker in the main panel, the system will fail.
And the sources mentioned this can actually look like a software glitch at first, right?
Yeah, that is the deceptive part. These severe physical faults often manifest on the app as confusing software bugs. You might see dropped Wi-Fi connections, randomly aborted charge sessions, or wildly fluctuating charging speeds.
But it's not a software bug.
No. In reality, they are critical thermal events. Loose connections under continuous high amperage create immense heat, which is a severe fire hazard.
Man, this is exactly why the expertise in our source material is so vital and why peace of mind is worth paying for. An EV charger isn't a DIY weekend project.
It absolutely is not. The state of California legally requires permits and official municipal inspections for EV charger installations.
Right. If you bypass that process and have, an unqualified friend wire a 240-volt circuit into your garage, you are instantly voiding the manufacturer's warranty on the smart charger itself.
And more importantly, you are creating a massive liability risk. If an electrical fire occurs, your homeowner's insurance will investigate the unpermitted work.
Which brings us to Copperfield Electric. They are the source of this expertise today, operating under California license number 1094740.
Yeah, they are a family-owned 24-hour electrician providing comprehensive services.
Right. Their service footprint covers a massive area across Southern California and Orange County. They are operating in Irvine, Costa Mesa, Anaheim, Santa Ana, Mission Viejo, Newport Beach, Tustin, Huntington Beach, Orange, Fullerton, and Laguna Beach.
That is a huge coverage area.
It is, and reviewing their service breakdown, what really stands out is that they handle the entire process end to end. You aren't just hiring someone to pull a wire through a wall.
Right, because they don't just run wires. The true value of a company like Copperfield Electric is their ability to act as a bridge.
Exactly. They handle the load calculations to determine if you actually need those CT clamps, pull the proper municipal permits, strictly adhere to correct wire gauge and breaker sizing, and guarantee the system passes county inspections.
And they ensure the physical foundation is perfectly matched to the smart software, even helping with the app setup. Plus, they offer upfront competitive pricing and a 100% satisfaction guarantee.
And 247 emergency electrical services, which is huge if a broader grid issue ever impacts your home.
They ensure that all the sophisticated software optimizations we've discussed today actually have a safe, robust physical foundation to operate on.
So it all actually works safely.
Exactly.
All right, so to summarize the core pillars of optimizing your EV setup, first, you transition away from guesswork and rely on smart software to actively manage power flow.
Yep.
Second, you respect the physical chemistry of your battery by strictly adhering to the 80-20 rule for standard daily driving. Third, you time your sessions for off-peak TOU hours to slash electricity costs. And finally, none of this matters without ensuring a safe, professional installation.
Those pillars establish a highly efficient baseline. But I will leave you with one final, fascinating variable to mull over regarding the physical science of charging speeds, and that is temperature.
Oh, temperature.
Yeah, the sources briefly note that extreme heat or extreme cold fundamentally alters how fast your battery will accept a charge.
Right, because of internal resistance.
Exactly. So I challenge you to think about this. If you've just finished a long drive on a scorching summer afternoon or left your car out in the freezing cold, how might letting your battery's temperature naturally stabilize before plugging it in completely change the efficiency of your smart charger?
Oh, wow, that is a brilliant point. The physical temperature of the cells dictates how willingly they accept those electrons. Thermal management is an entirely different layer of the puzzle.
It really is.
Well, thank you so much for joining us on this deep dive into smart EV charging and the incredible technology managing our power grids.
It was a pleasure. Thanks for having me.
If you are ready to stop guessing, start optimizing, and you live anywhere in the Orange County area, make sure to check out Copperfield Electric for a free quote to get your own home set up professionally permitted and installed. We'll catch you on the next deep dive.